So let's go on page 114. Okay, so we looked at some basic identities. We learned about what some of them were on Monday. So now we're going to simplify this. This is going to lead into proving, which leads into solving, and leads into a whole lot of other things, okay? So it says to simplify a trigonometric expression means to rewrite it as a numerical expression or in terms of a single trigonometric function. Identities are useful in simplifying trigonometric expressions. So it's basically the skills that you're going to have to use to simplify down your equations, because we're going to use some basic algebra skills for those as well. But sometimes we need to substitute things in just to make things cancel out and clean them up a little bit. Again, we're not changing the what they're equal to, we're just changing the way it looks. It's a lot like taking the square root of 8 and making it 2 square root of 2, or taking 4/8 and making it 1/2. Same concept. So here are some strategies, okay? And these are very important because the questions I get from these all the time are like, how do I even know to start? How did you know to do that? Well, sometimes it's a guess. Sometimes it's a, well, this is my only option, so I'm going to do this and see what happens. You very well may go down the wrong road and get nowhere and have to back up and start over and do something different. That's what happens with these. But the more you do them, the more comfortable you are with them and the more sense it makes, okay? So here's some strategies. First one is to rewrite using reciprocal and quotient identities, which those are the ones you already know. Look for the Pythagorean identities or possible ways to create one. Okay, so you got Pythagorean identities on there as well. There's 3 of them. Combine fractions using a common denominator. Okay, and break fractions apart. So putting them together and taking them apart are things that are going to happen a lot. And some factoring as well. All right, so let's start with number 1. Let's see what we could do. So our first strategy is to try and rewrite using reciprocals and quotients. And this is not an equation. We are not solving. We are just trying to simplify this down to just one little expression, okay, or one term. So what is the reciprocal of secant? Cosine. So this is going to be 1 over cosine theta minus, now when it says use the reciprocals and quotients, that doesn't necessarily mean put everything in reciprocal. That usually means you're trying to get it maybe in sine and cosine. So I'm going to leave sine as sine, right? So this is going to stay sine theta. And then sine theta could be, tangent theta could be rewritten as what? What? Sine over cosine. So this is going to be times sine theta over cosine theta. Okay, everybody with me so far? So what we just wrote is equivalent to what we started with. It just looks different. So now I'm going to clean it up some more. This is going to be equal to 1 over cosine theta minus, well, what's sine times sine? Sine squared. So this is sine squared theta over cosine theta. Okay. Everybody good so far? Now, I have 2 fractions. Do they have common denominators? Yes, so I can put them together. And this equals 1 minus sine squared theta over cosine squared theta. I'm sorry, not just cosine theta, not cosine squared. Everybody good so far? So now I've got something with some squared. So anytime something's squared, there's a possibility that the Pythagorean identity could work in there, right? So do you have a Pythagorean identity that uses sine squared? Yes. And so what that says on there is that sine squared theta plus cosine squared theta equals 1, right? So I can have different versions of this, right? This is what it says on your little cheat sheet, on your reference sheet. But if I have 1 minus sine squared, like so if I subtract sine squared from both sides, so I have 1 minus sine squared, what's that going to be equal to? What happens if I subtract sine squared from both sides? So I get 1 minus sine squared, what will be left over here? Cosine squared. So cosine squared is going to be equal to 1 minus sine squared. Does that make sense from that? So instead of this 1 minus sine squared in the numerator, I can change that to cosine squared theta. So now I have cosine squared over cosine. That's just like x squared over x, right? So this would reduce down to what? Cosine. So I'm just left with cosine theta. And I simplified it. And if it's something that I have to calculate, wouldn't this be much easier to calculate than what they gave me? Right? And they have the same value. So if I had a theta, I could substitute it in. I'm going to get the same thing whether I find the cosine or whether I do all that mess up there. Okay? Ask me questions if you have questions. If I lost you somewhere.
For the second step, you have 2 cosine thetas, but when you combine them, you don't like add a square, right? Because of the same thing.
because it's like 1/3 plus 1/3 is 2/3. They have a common denominator. When you add and subtract fractions, you don't do anything with the denominator. Yes, sir. What did I do? Is that what you're asking me? Like, how did I get this? Is that your question? I don't know what you're asking me. You're just, okay. So on here, your Pythagorean identity, you have this purple thing right here, right? So if I subtract sine squared from both sides, I'm going to get cosine squared theta, oh, I left off my theta, equals 1 minus sine squared theta. So I substituted 1 minus sine squared theta with cosine theta. Okay, yes? Yes? No, maybe? Okay. All right. Let's, we're going to write some other stuff on that. So on your green paper, I'm going to have you write something here in just a second. Okay. So I want you, so on your green sheet, we're going to add some stuff, okay? And you can write them both underneath, like we're going to write 2 different versions of each one of these. You can maybe write them both underneath if you write small, but so I can write big enough for you to see, I'm going to write one above and one below. So this sine squared theta plus cosine squared theta equals 1. If I subtract sine squared theta from both sides, I am then left with cosine squared theta equals 1 minus sine squared theta. Do you agree with that? It's the same thing, right? And then I also, if I solve for sine squared, I'm going to have sine squared theta equals 1 minus cosine squared theta. So have them written on there so you can recognize that better. Now, when you're given one of these sheets to use on a test or a quiz, it's not going to have the extra ones written on there. But by then, hopefully we'll have done it so much that this makes a little bit more sense to you, okay? Then for tangents, or for the middle one then, let's solve for tangent. So tangent squared theta would equal secant squared theta minus 1. And I could also solve for 1. 1 equals secant squared theta minus tangent squared theta. Now, you can add in any order, but you can't subtract in any order. So that secant squared, minus tangent squared, it's important that it's in that order. Then for the last one, we'll have cotangent squared theta equals cosecant squared theta minus 1. And then another version of that would be 1 equals cosecant squared theta minus cotangent squared theta. So I just basically, there's 3 things in each equation. I just rewrote it where each thing is solved for by itself, okay? So now, when we look at this, and you can refer to this, when we had that 1 minus sine squared theta, it's equal to cosine theta, and that's why I just substituted it in. Okay, does that help? And you having them actually written out right now like this will help you identify them a little bit better. Just make sure that you have written them down correctly. Okay, are we good? All right, so let's go back to what we were doing. This one, there we go. All right, so number 2. Let's move on to number 2. I've got sine of A plus cosine of A times tangent of A. So again, I can do a quotient thing. I can change my tangent, right? So I'm going to make this sine A, this is equal to sine A plus cosine A times, what's tangent? Sine over cosine. Okay. So then what can I do?
You could cancel out.
I can cancel out what?
Cosine A.
Cosine A and cosine A. Very good. So this leaves me with sine A plus sine A. It is. It's exciting. They're like little puzzles. And then what's sine A plus sine A? 2 sine A. 2 sine A. You're not multiplying. You're adding. 1 monkey plus another monkey is 2 monkeys. Okay. No monkeys squared. Okay. And then we're done. No square monkeys here. Okay. All right, everybody good with that? All right, so now let's look at number 3, because there are 2 different ways to handle this, and I want to kind of look at both of these and figure out what we could do. And, oh wait, is this the one where it was two different ways? Let me make sure that I'm not lying to you. Because one of these I wanted to do two different ways. Maybe not. Okay. All right, but let's look at number 3. So on number 3, I've got cotangent squared u minus cosecant squared u. So I've got some options. What's one option that I could do? Okay, so I could substitute for cotangent, right? Or I could substitute for cosecant, either one of them, right? Which one's going to be easier to substitute for? Okay, it's a matter of opinion when I ask which is easier, but here's why I think cotangent is safer anyway. If I substitute something for cosecant and it's 2 terms, I got to distribute that negative, and that's a mistake we could make, right? That's a mistake that happens all the time. So we could substitute for cotangent, okay? And it's because it's already positive. So when I substitute for this, so on your little chart that you were looking at, because I'm not going to flip back and forth every time, we wrote down that cotangent squared is equal to, what is it? Cosecant squared u minus 1. Then we minus cosecant squared u, right? Because I still have to use that second part. Everybody with me? Okay, so then what am I left with? Negative 1, because I get cosecant minus cosecant. I just got negative 1, and that's my answer. Okay? So let's look at, we're going to actually work this one a second way just because I want you to see that you can work it completely differently and get the same answer. All right? So no need arguing about who's right if you start it differently. So let's say, because sometimes people don't see this, what they see is, ooh, I can do reciprocals and quotients, and that's absolutely fine. So here, cosecant is 1 over what? Sine. And since it's cosecant squared, this would be 1 over sine squared. Okay, makes sense? What is cosecant squared? I'm sorry, I'm sorry. Oh, Lord have mercy. I was using the green one. I really should start from up here. So let me fix that. I'm sorry. Dang it. I'm sorry when I mess up like this. Did you see what I did? I accidentally started from here. I meant to start from here, and I wasn't paying attention. So let's start with the cotangent. What cotangent is what is a quotient? Is a quotient. Is it cosine over sine or sine over cosine? Cotangent is cosine over sine. The cos are, so cosine is, so I should have made this, yeah. So, oh my God. All right, so my cotangent squared was going to be cosine squared u over sine squared u. Everybody with me? Okay, because I'm really starting at the very beginning. I accidentally used the green. All right, so that's just made the first one into a quotient. So then minus cosecant squared, so that's minus 1 over sine squared u. Everybody good with that so far? Now that I've not messed up again. Now, I have 2 fractions. They have a common denominator. That's good. I don't even have to get one. I can combine them together and get cosine squared u minus 1 over sine squared u. Everybody with me so far? So what is cosine squared u minus 1? Is it sine squared? Is that what matches on your sheet? Look at it. No. Okay. So here's what we have. Theta. Leaving off my thetas. And sine can come first. It doesn't matter. But cosine squared minus 1, if I subtract the 1 over here, don't I have to subtract the sine over there? So this would be a negative sine squared. Does that make sense why? And if you need to take this and manipulate it, so this would give me cosine squared theta minus 1 equals negative sine squared theta. You don't necessarily have to write this stuff out every time if you can kind of reason through it, but you got to be careful with how it's backwards with the negatives. You can really get you messed up there. So when I substitute, I'm actually substituting a negative sine squared u over sine squared u, and what does that give me? Negative 1. You get the same answer. Now, I know your first thought is, well, the first one was easier. Well, yeah, but whatever you're doing, you're not necessarily always going to see the easiest one. You're going with the one that makes sense to you that you can start, okay? You will, as long as you don't make up math along the way, everything you're doing is legal, you'll still get to the end result. And it'll all work out nicely. That's the whole purpose of it, okay? It'll get prettier, not uglier. Questions? This one? Okay, so on your sheet, right, the one that's printed on there says that we have that cotangent squared theta plus 1 equals cosecant squared theta, right? And so I wanted to substitute just for cotangent, so that means that cotangent squared theta equals cosecant squared theta minus 1. You agree with that? Okay, so this part right here got substituted with this. And then this part came from here. Does that make sense? And then the cosecant subtract out. Okay, does that help? Okay, good. Anything else before we move on? Okay. All right, let's look at number 4. Wait, what? Okay, let's look at number 4. So on that, with that sign in the numerator, I could distribute it in, but I don't think I really want to. What cancels out? Why would they? It cancels out with what? Right, but you're adding. See, these are being added, not multiplied. Okay, so we could do the quotients and get those in there if we wanted to, but that's going to be a fraction and a fraction. We'll try and eliminate that as much as we can. Isn't this the same thing as saying sine x over cosine x times tangent x plus cotangent x? Would y'all agree with that? It's the same thing, right? And if you see that, you don't necessarily have to write this step. I mean, here I want you to in your notes. I just don't want to lose you, but I wanted to make sure you knew where it was coming from. Then what is sine over cosine? Tangent. So this is equal to tangent x times tangent x plus cotangent x. You with me? So now I'm going to distribute. What's tangent times tangent? Tangent squared. Okay, and then what is tangent? So I did that one. What's tangent times cotangent? What's 3 times 1/3? What's 2 times 1/2? What's 5 times 1/5? So tangent times cotangent, that's tangent times 1 over tangent, right? So when you multiply these, it's just plus 1, right? Now remember, your goal is one term, okay? Do I have something I can substitute for this? Look at your sheet. Don't stare at me and stare up here. Tangent squared theta plus 1 equals what? Secant squared. So this is secant squared x. It's no magic. It's coming from your reference sheet, right? Everybody good with all that? Any questions at all? Okay. All right. So let's look at number 5. Can I cancel out the cosecants? No, that makes no sense. So I could do reciprocals and quotients here. That will give me fractions and fractions in the second one, so I think maybe we'll try and hold off, see if there's something else. But if you have two things, you can combine them by getting a common denominator, all right? What would our common denominator be here? Cosecant theta, right? So my common denominator is going to be cosecant theta. Oh, let me do this separately first. So in the first fraction, if my denominator becomes cosecant theta, what's the numerator going to be? No. If I want to get a common denominator, this already has that in there. So this second fraction is going to be cotangent squared theta over cosecant. Like that one doesn't change, right? Yes, the first one has to be multiplied. So this is like over 1. I have to multiply it by cosecant over cosecant, right? So this becomes cosecant squared theta in the numerator. Because I had to multiply this by cosecant theta over cosecant theta, right? And so cosecant times cosecant is cosecant squared. Okay, it's just like if I have 1/2 plus 1/3, or well, I don't know, maybe like 2 plus 1/3 is I guess what I should have done. And then so I have to multiply this by 3 over 3, right? Because the common denominator is going to be 3, so I had to multiply the first one by cosecant over cosecant. Okay, does that help? All right, so now I have 2 fractions. I can put them together, and I get cosecant squared theta minus cotangent squared theta over cosecant theta. Do I get to cancel out any cosecants right here? No, I do not. That makes no sense because there's subtraction there. But what is cosecant squared minus cotangent squared? 1. It is 1. Okay? So this gives me 1 over cosecant theta. But I don't get to leave it like that. What does that become? No. Sine. So close. Sine. Okay, everybody good with this? Got to be able to cut a common denominator. All right, so let's look at number 6. And number 5, we took 2 fractions and we put them together. In number 6, we're going to take the fraction and take it apart. Listen very carefully. You only get to do that when you have addition and subtraction in the numerator. Do you see how here I had these 2 and then I put them together? So like I could split this back apart and make it back into these 2. That's basically what we're doing here to start with. So this is going to give me cosecant of beta over cosecant beta minus sine beta over cosecant beta. Okay, everybody with me so far? You understand how we split that up? Okay, no splitting of the denominator, only the numerator. So then what's cosecant over cosecant? 1. Okay, 1 minus, now this is sine divided by cosecant. So that would be the same thing as sine multiplied by the reciprocal of this, yes? What is the reciprocal of cosecant? Sine. So this becomes sine of beta times sine of beta, which means I get 1 minus sine squared beta. Everybody understand where that second sign came from? It's the reciprocal of cosecant. Dividing by something is the same as multiplying by the reciprocal. Mm-hmm. All right, so then what's 1 minus sine squared? Look at your Pythagoreans. Cosine squared. Okay. All right. Everybody good with that? Any questions at all? Okay. Let's look on the next one. Number 7. All right, so I have 2 fractions. Before I worry about like reciprocals and stuff, I think I want to go ahead and get my fractions together, which means I need a common denominator. Okay? So what would my common denominator be? Sine u times cosine u, right? So I'm going to have this first fraction. My denominator is going to be sine u cosine u, which means that this first fraction would have to be multiplied by what over what? No, this first fraction. Like in order to cosine over, no, I can have to multiply it by a value of 1. This denominator is missing the cosine, so this has to be multiplied by cosine over cosine, right? So this gives me secant u cosine u minus, and then same denominator for the second one, sine u cosine u. And then this fraction has to be multiplied by what? Sine over sine, right? So this would be sine squared u. Everybody with me so far? Okay, so now I have 2 fractions. They have the same denominator. I can put them together, but I can do a little bit of cleanup at the same time. What is secant times cosine?
Sine. No.
What is secant the reciprocal of?
Oh, it's 1
Cosine. So this is like 1 over cosine times cosine. What does that give you? 1. So I get 1 minus sine squared u over sine u cosine u. You could even at the beginning like that. That'd be fine. I just didn't want to lose anybody at the first time we did it. All right. Any questions at this point? Stop me if I've lost you, if I need to repeat something. Okay, I'd rather you stop me now than be too totally confused. All right. So then, can I cancel this sign with one of these? No, because there's subtraction, right? So, what can I put in the numerator? Cosine squared. 1 minus sine squared is cosine squared over sine u cosine u. Now can I simplify some cosines? Yes, I can cancel the 1 in the denominator with one of the ones from the numerator. This gives me cosine u over sine u. And what is cosine over sine? Cotangent u. And you're done. It is. It's actually, and you know what's funny? It's easier, and we're not actually finding values. And it used to be that you were like, what happened to all the numbers? Just give me numbers. It's better. No, this is really better, okay? And they're like puzzles, so it's kind of like some satisfaction when you get to the end. You're like, oh, I did it, and I don't think I made anything up. All right, so let's look at number 8. Can I split this fraction? No, because you can't split the denominator. You can only split the numerator, right? So instead, we are going to work with some quotients and reciprocals. But I'm going to start with just the denominator first. So I'm going to make this tangent alpha over, well, what is secant the reciprocal of? Cosine. So this is going to be 1 over cosine of alpha minus cosine of alpha. When you're doing the reciprocals, most of the time you don't want to change them into secant and cosecant, like you're trying to kind of get everything into sine and cosine. So now I need a common denominator in my denominator. Okay? So think about that. I'm going to rewrite this. You have to not let this stuff freak you out because it's not that bad. You just have to be able to read what you're writing. I'm going to leave tangent of alpha in the numerator. In the denominator, I need a common denominator, right? And what's that common denominator going to be? These two things, it's cosine. They're both going to have cosines, okay? So when you do that, do you see how I got my common denominator and I had two terms here, but I really could have done it all at once. And so since my common denominator is going to have to be cosine, right? So I got cosine of alpha here, which means that first fraction already had that as the denominator, so I just have a 1. This second fraction, to get a cosine in the denominator legally, I have to multiply by cosine over cosine. So this is 1 minus cosine squared. Okay, everybody with me so far? Now, I would like to get rid of the whole two-term thing if I can. Do I have something I can substitute for 1 minus cosine? What is it? Sine squared. Good. So I have tangent alpha over sine squared alpha over cosine alpha. Now, you want to be careful because it's not exactly tangent in the denominator. Why not? Because one's squared and the other one isn't. So just be careful with that. So what I want to do is I'm going to make tangent into the quotient also, which I know you don't love fractions and fractions, but it actually makes this easier in the end. So you have to keep up with what you have. The numerator, which is tangent, right? Tangent becomes sine over cosine. So I'm going to have sine alpha over cosine alpha. In the denominator, I still have sine squared alpha over cosine alpha. Everybody with me so far? So all this is a fraction divided by a fraction. And your rule when you divide by fractions is you take the sine of alpha over cosine alpha, and instead of dividing by the fraction, you multiply by its reciprocal, which is cosine alpha over sine squared alpha. Okay? You should not skip steps. It's a bad idea because you may think something's going to happen and then it doesn't, or like things cancel out. So you should be very diligent in what you're writing so you don't confuse yourself. Can I reduce some stuff? Yes, the cosines cancel out because this is multiplication. This sine cancels out with one of these. So that leaves me with 1 over sine alpha, which is what? Cosecant alpha, no squareds. And be careful with your 2's and your squareds. It's easy to kind of get those in the wrong place too. Ask me questions if you have questions. Anybody? This gets better, I promise. It just takes some practice. You got to be familiar with it. Don't be hating on it. But if I've lost you, let me, you know, you'll actually like these in the end. Like it's like some of this stuff is kind of cool, actually. All right, so let's look at number 9. Okay, so can I cancel anything out in number 9? No. I need to go ahead and multiply what's in the numerator. Is this any sort of special case that we have? It is. Do we know what it's called? We're not factoring, we're multiplying. If I have like x minus 3 times x plus 3, what's that called? It's the difference of squares. Okay, so this right here would give me what? X squared minus 9, right? Like we don't have to do all the crazy stuff, because it works out that way. So y'all have got, I've been telling you since the beginning, you've got to be rock stars at multiplying this stuff and rock stars at factoring, because we're going to be factoring this stuff as well, all right? And if you can't do factoring with x's, I don't know. So this becomes, it's all a big joke until we have to retake pre-cal, so be quiet. All right, so this becomes cosecant squared x minus 1. It's that easy, right? Okay, because of the difference of squares, not just because you get to multiply the first one and the last one. You said, no. Because remember, and I know it's kind of weird, but if I take cosecant of x and I square it, the way we write it is like this, because it's actually the cosecant value that's squared. The x itself doesn't get squared. Like it gets squared after you take the cosecant. So this is how you write it. You would never write it with the square on the outside. Does that make sense? And I know it's weird at first, but that's just what happens when it gets squared. Okay. All right, over cosecant squared x. Okay, so do we have something we can substitute here? Yes, what's cosecant squared x minus 1? Cotangent squared x. And every time I'm asking those questions, actually look at that sheet, because if you're not looking at it now, when you have to go look at it on your own, it's not even going to be familiar to you. Over cosecant squared x. So now at this point, the quotients would be good in reciprocals. So cotangent is what over what? Cosine over sine. So this gives me cosine squared x over sine squared x in the numerator. The denominator would be 1 over what? Sine squared, right? Sine squared x. So now again, fraction and a fraction is not that bad, because we just do cosine squared x over sine squared x times sine squared x over 1. Right? I just multiplied by the reciprocal. So now what can I do? Cancel out the sine squareds, and I'm just left with cosine squared x. That's fun, right? See how much fun that is. Okay, let's look at number 10. This 1 plus sine theta in the denominator, can I replace that with like cosine theta? No, because there's no squared, so be careful with that. So there's not a Pythagorean anything here. So I'm thinking I'm going to need to go ahead and make this into the quotient. So we're going to make this sine theta over cosine theta plus cosine theta over 1 plus sine theta. Okay. Everybody with me at this point? Can I cancel those cosines? No, because that is not multiplication. Exactly, I'm adding, so that's a big fat no on that one. I gave a quiz in pre-AP today. They were canceling that stuff out all over the place. It was just a hot mess of people making up math. Okay, so don't go doing that just because it looks different. But what I have here, and really doing any other quotients or reciprocals is not going to get me anywhere. But I have two fractions. I need to put them together, so I need a common denominator. The easiest way for this stuff, for you to get a common denominator, is just to take the two denominators and multiply them together, right? So my common denominator is going to be cosine theta times 1 plus sine theta. I'm not even going to distribute that. We're just sticking them together, okay? It's like x times y. So in the numerator then, we're going to do this without writing it as separate fractions first. This fraction right here has to be multiplied by a fraction made up of 1 plus sine over 1 plus sine, right? So that means I get sine theta times 1 plus sine theta, right? That comes from the numerator of the first one. Plus, and then this one would have to be multiplied by cosine over cosine, so then this gives me cosine squared theta. Everybody with me? Just because it starts to look a little crazy does not mean that it's difficult, so just hang in there with it. It'll be fine in the end. It all turns out being pretty. So in the numerator, I'm going to distribute, and I'm going to get sine theta plus what? Sine squared theta plus cosine squared theta all over cosine theta times 1 plus sine theta. Everybody with me so far? Because all I did was distribute in the numerator there. Can I cancel anything out at this point? Like just mark things out like from numerator and denominator, like my signs? Can I go, oh, I can cancel that with that? No. All right. Do you see anything I can substitute for, though, in the numerator? What? What is sine squared theta plus cosine squared theta? 1. So this is equal to sine theta plus 1 over cosine theta times 1 plus sine theta. Yeah. Everybody good? All right, so is there anything I can reduce now? Yes. This, like, I can't cancel the signs out, right? But this whole thing cancels out that way, and I get 1 over cosine theta, which is what? Secant theta. And you're done. Okay. Questions about that? Anything? All right. So we're going to do 11 and 12 tomorrow. I'm going to go ahead and give you your assignment so that you have it. And you can get started on it, but we're going to do a couple more together tomorrow with the factoring and stuff. Okay? So if you're not here tomorrow for whatever reason, make sure you watch the video.